Assalamu alaikum wa rahmatullah. Hello, good morning, everyone. My name is Ayub Ilfallah, and I am master student at UTM University, Faculty of Mechanical Engineering. Today, I will be presenting my research on predictive maintenance of pumps in the oil and gas industry to improve and enhance operational efficiency. Oil and gas sector relies on pumps, especially for operation and extraction. However, the additional maintenance often fails to prevent failures before it happens. And we can say that predictive maintenance offers proactive solutions. Unexpected and unplanned pumps failures remain common inside the oil and gas factories. Scheduled maintenance leads to unnecessary costs, especially in time and money, which is sometimes required to spend high budget about that. Need for predictive methodology to minimize downtime that especially sometimes it happen during the rush hour of seasons for the factories. The main goals from this research is to develop a data-driven model to predict failures before it happens, especially inside the fields or factories, and also identify key influencing factors, validate model reliability, and recommended integration into existing practices. This research focusing on using analysis of historical sensor data and development of machine learning models, validation with real-world data, and in this case we will focusing on temperature and vibration, pressure and flow rate, and vibration that give us indicated about whether if the pump still need to measure overall or not. I aim to answer key questions such as what causes pump breakdown, that pump sometimes has a breakdown which is lead to if there is no spare pumps, for example, need to shut down or close the system. And how can historical data support failures prediction? And how accurate is the predict model that we will create? And how can predictive models reduce downtime, saving time, saving money, and keep the factories running? My hypothesis is that sensor data such as temperature, vibration, and others can be used to build accurate models to avoid failures and predicting pumps failures before it happens. Machine learning enables detection of failures pattern. Lecturer suggests a growing shift from reactive to predictive maintenance. Softwares such SVM, random forest, and neural networks commonly used in this case. Traditional methods miss early failure signs that use traditional methods, which is unable to detect exactly pump issues. Recent studies highlighted that fixed models need high-quality sensor data rather than that one already exists in the field or industry. Emphasis on feature selection and processing. Predictive analytical is gaining traction in the industry. This research follows five phases: collecting data, then processing it, after that model development, after that we will do validation for this model, and integration, also quantitative and data-driven approach. We use sensor data such as temperature, pressure, vibration, and uh, flow rate. And I guess the most important one is vibration analysis because that give us indicate about pumps issues, which is give us the specific bearing lifetime and sometimes give us also mechanical seal before it crash down. And for this, we will cleaning and normalizing the data, feature engineering, use PCA labeling, and time windowing applied. We expect to achieve from this research reliable predictive model that we will create and significant downtime and cost reduction, which is most of the companies looking for this, like reducing the cost and downtime reduction. Integration framework for maintenance system. In conclusion, we can say that predictive maintenance improves efficiency and safety, and using data-driven models enable early fault detection that might happen inside the factories, especially during runtime in the season. And uh, all or most of the companies try to minimize the downtime and breakdown issues. And for no reason, sometimes we can see that pump just like failure because the lifetime for peeling, for example, or you can see, or even problem with the manufacturing that could lead to failure before it already happened. So that's it, and I would like to thank you for having me in your university, and Assalamu alaikum wa rahmatullahi wa barakatuh.